All right, sorry for that interruption. So we have lead 1, Cl2. The other product then, +1, -1, those charges cancel. So we just need one of each. So this is the reactants, and these are the products. Now, we're not done because it said don't not only predict the products, but let's balance it as well. So, to balance this equation, we look at how many of each are on each side. So lead, we have 1 on the reactant side. The NO3, since it stays together, we can keep it together. So on the reactant side, we have 2 NO3s. Sodium, there's just 1. Chlorine, just 1. Looking over at the product side, we have 1 lead, 1 NO3, 1 sodium, and 2 chlorines. So the things that aren't balancing are the NO3s and the chlorines, it looks like. Our leads and our sodiums, 1 of each on both sides. So to change that, we have 2 NO3s on the reactant side. We need 2 on the product side. So we're going to go ahead and put a 2 there. That changes my NO3s, but it's also going to change my sodiums. So now I go back over here. Since I have 2 sodiums on the product side, I need 2 on the reactant side. That's also going to change my chlorines, which is good because that's what I needed to do anyway. So this is the balanced chemical equation. So now let's look at the next problem, number 4. So for number 4, it's giving us a reaction, and it's actually balanced already. We have sodium sulfate reacting with carbon, like sodium sulfide, and carbon dioxide. It's asking, what is the molar ratio used to determine how many moles of carbon are needed to fully react with sodium sulfate? So this is where you're going to use the names to figure out which 2 you're comparing. Okay? They're asking about moles of carbon and moles of sodium sulfate. So find those 2 reactants or products on here. So moles of carbon, that would be this guy here, and then moles of sodium sulfate, because it says sulfate, not sulfide. So this is sulfate. Okay, this is sulfide. So know the difference in the names because that's important here. So sodium sulfate is this guy. So when it's asking for moles, remember, a balanced chemical equation, the coefficients represent the number of moles. So we're comparing the coefficients of carbon to the coefficient in front of sodium sulfate. So that is a 2-to-1 ratio. So that's a pretty straightforward one. Let's move on to number 5. So number 5 is another one where we're doing a balanced equation, and they're giving us the names of the reactants, also the names of the products. So we're going to take those names and come up with the chemical formulas. So we have copper metal. So when it says copper metal, that means copper in its elemental form. So it's just going to be Cu, neutral copper. Okay, most likely it's going to be a solid. But it's not specifically asking for the state, so I'm just going to come up there anyway. So we have copper metal reacting with silver 1 nitrate. So let's take that silver 1 nitrate and make that into a chemical formula. So silver is Ag. Since there's a 1 in Roman numerals, that means it's got a +1 charge. Nitrate, we looked that up in the number 3. It was NO3 with a -1 charge. So the chemical formula of that guy, those charges cancel, so you only need 1 of each. It would just be AgNO3. That's going to be aqueous. How do I know that? Because of the precipitation, the solubility tables. Okay, if you look up NO3 on the solubility tables, NO3 is soluble all the time, no exceptions. Okay, so that's how I know it's aqueous. It's producing silver metal, so silver is now by itself. Oops, I don't know why I drew an arrow there, that should be a plus sign. And copper 2 nitrate. So we have copper with a +2 charge, that's what that Roman numeral 2 means, it's copper 2 plus, with NO3 -1. Now, the charges don't cancel, so we do the crisscross method. It means we'll have 2 nitrates and 1 copper. So, 1 copper, 2 nitrates. Parentheses around the NO3. And the 2 on the outside of the parentheses. Now, we need to balance this chemical equation. Single replacement reactions are pretty easy to balance. That's it right there. So we have 1 copper, 2 silvers, 2 nitrates, 2 nitrates, balanced. And doesn't tell us to label the type of chemical reaction, but it is a single displacement reaction or single replacement reaction. All right, the next one does specify that it's a single replacement reaction, and it's giving us aluminum to hydrochloric acid. So aluminum, in its pure form, it doesn't say it's attached to anything, it just says aluminum, so I'm going to say it's a solid piece of aluminum, and it's reacting with hydrochloric acid or HCl. Now hydrochloric acid is always diluted when we use it in the lab, so that's how I know it's aqueous. It's never going to be an L here, so we're going to be liquid, because liquid would mean it's in its pure form. We're not going to have pure 100% hydrochloric acid, we're always going to dilute it with water. So that's why the AQ is there for that one. Now it's saying it's a single replacement reaction, so we're following the scheme A plus BC. So we have an element by itself reacting with a compound, and it's going to switch places. So A is going to kick B out, leaving B by itself, and then A is going to be with C. In this case, A is aluminum, B is hydrogen, C is chlorine. So aluminum is going to be with C, chlorine, on that side of the reaction. But remember, new partners, new subscripts, so we need to see what this is going to look like. If we have aluminum with chlorine, to figure out the chemical formula, we need to know the charges. So to figure out the charges, we look at the periodic table. Aluminum, it's the metal along the zigzag line, the only metal along that zigzag line. It's in group 13, so it has a +3 charge. Chlorine is a halogen, so it's got a -1 charge. We do our crisscross method. We're going to need 3 chlorines for every 1 aluminum. So 1 aluminum, 3 chlorines. Now B is going to be hydrogen. But remember, hydrogen never just hangs out by itself. It's one of those diatomics in nature, those 7 that we looked at. Hydrogen was one of them. And then it was nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Okay, so all of those elements, they're not stable by themselves like the metals are. Okay, aluminum, metal, stable by itself. It doesn't need to hook up with another aluminum to be stable. But hydrogen's not. So hydrogen always finds another hydrogen to form H2. Now, this is going to be a gas. And as for aluminum chloride, I would have to look up on the solubility tables to see if this was a solid or if this was aqueous. All right, but we're not done because we needed to do this to figure out the answer to the question. It's asking what would be the correct mole ratio of aluminum to hydrochloric acid. Well, in order to figure out the correct molar ratio, remember, molar ratios need a balanced chemical reaction. This isn't balanced yet, so I need to go ahead and balance it first. So make a list. We got 1 aluminum, 1 hydrogen, and 1 chlorine. Over on the product side, 1 aluminum, 2 hydrogens, 3 chlorines. All right. Let's do chlorines. No, let's do hydrogens first, fine. So I put a 2 here, that gives me 2 hydrogens, it gives me 2 chlorines. Not good enough, because I need 3 chlorines, right? So let's switch this to a 3. That also changes my hydrogens to 3. Well, that's not going to work either. So basically, I'm going to keep going back and forth. What I'm going to realize is that an odd number of chlorines isn't going to work out for me. So I'm going to go ahead and put a 2 here. I'll get 2 aluminums, 6 chlorines. So to get 6 chlorines, I'm going to put a 6 here. It's also going to change my hydrogens to 6. But I need 6 hydrogens on the product side as well. So if I put a 3 here, remember coefficient times subscript, so 3 times 2 will give me 6 hydrogens. Now everything's balanced except for my aluminum, so if I put a 2 here on the reactant side, I've now balanced my aluminums. So 2 aluminums on both sides, 6 hydrogens on both sides, 6 chlorines. So that's my balanced chemical reaction. Now, it wants a mole ratio, so that means I'm comparing 2 different elements or compounds. Which 2? Aluminum and hydrochloric acid. So I'm looking at the coefficients in front of aluminum and in front of hydrochloric acid. So it is a 2 to 6 ratio, or if you want to simplify that down, 1 to 3. Both would be correct. 1 mole of aluminum will need 3 moles of HCl to fully react. What is the mass in grams of 1 mole of copper atoms? Oh, so this is that strangely worded one that I like to go over. Let's take a look at that. I have 1 mole of copper. Well, looking at the periodic table, copper is 63.55. So what that question's asking in a weird way is, what is the molar mass of copper? So 1 mole of copper is equal to 63.55 grams. So I know this because that 63.55 grams per mole is the molar mass. And this is saying that 63.55 grams of copper is equal to 1 mole of copper. That's what that per mole stands for. So this would be the correct answer. 1 mole of copper is equal to 63.55 grams. So, strangely worded, but easy to figure out once you understand what they're asking for. Okay. So let's move on to number 8. In a reaction performed in lab, 11.15 grams of product was recovered. If the student calculated she should have recovered 12.96 grams, what is her percent yield? So remember, percent yield is actual over theoretical times 100 to get it in a percent. So her actual yield, she said, was 11.15, but she discovered that she should have recovered, so her theoretical was 12.96. And of course, don't forget to multiply that by 100 to get it in a percent. Now remember, the higher the percent yield, the better, because that means you recovered almost everything you possibly could. 86%. 466 would be 86.03 to be exact. Just good, the higher the better. She got 100%, that means she recovered everything she possibly could have in the reaction. The last one, how many grams of Silver 1 chloride will be produced when 92 grams of silver nitrate react with an excess of calcium. So let me get this reaction right up here. To AgNO3. So they're saying how many grams of AgCl, so question mark by that guy, will be produced when 92 grams of AgNO3, so you get 92 grams of this guy. And it's an excess of calcium chloride. So that means that silver 1 nitrate is the limiting reactant here. So they're saying we have an excess of the other reactant. So we're trying to figure out how many grams, you put a G here so I know where I'm going. So I have a step-by-step going through problems like this, grams of one reactant or product to grams of another. So what you want to start with, of course, is the grams given. In this case, my plan will be to start with the grams of silver nitrate. Now when I'm trying to get to grams of a different element or compound, I can't compare grams and grams. I have to get it in moles first so that I can use these coefficients, my mole ratios, to compare the two. So my very first step is always to get it in moles. To go between grams and moles, I'm going to need the molar mass. Once I have moles, now I can compare the two. So I can figure out my moles of silver 1 chloride by using a mole ratio, those coefficients in front of each. Now, I can't stop at moles of silver 1 chloride because they asked me to go to grams, so my last step then will be to get to grams. And whenever we go between grams and moles, we need molar mass. So let me write everything I need over here. I'm going to start with molar mass of silver nitrate. So silver, you want to write the atoms you have of each and then the molar masses of them. So for the atoms, you're using the subscripts. So I have 1 silver, I have 1 nitrogen, and I have 3 oxygens. Silver, 107.9. Nitrogen is 14 something, 14.01, and then oxygen is 16. Let me calculate that quickly. We get 107.9 plus 14.01 plus 3 times 16. And that's grams per mole. So that's the molar mass that I'm going to use in this step. Once I have moles, then I need a mole ratio. Mole ratio of what? Well, the two I'm comparing. I'm comparing silver nitrate to silver chloride. So I'm looking at the coefficients in front of silver nitrate and the coefficient in front of silver 1 chloride. It's a 2-to-2 ratio, or if you want to simplify that down, 1-to-1. Doesn't matter how you use it. So it's 2 moles of silver nitrate is going to produce 2 moles of silver chloride. Last but not least, I need the molar mass of silver chloride. So silver we have up here, one of them at 107.9. For the chlorines, I have one of them at 35.5, is that what it is? 35.45. Adding those together, 107.9 plus 35.45 gives me 143.35 grams per mole. All right. So I have all the steps that I need. I'm going to start now with my grams of silver nitrate. I'm going to start with my 92.0 grams. Using my molar mass of silver nitrate, that 169.9, I'm going to divide by the molar mass, 169.9. So my grams are canceling. Now I'm here, moles of silver nitrate. Now I'm going to use my mole ratio, and it's a 2 to 2, so I could essentially skip this step because it's not changing any numbers. So I have 2 moles of silver chloride, 2 moles of silver nitrate. And that is so that I can cancel out my moles of silver nitrate. So 1 there. This was to get me into moles of silver 1 chloride. So my last step is to use the molar mass of silver 1 chloride, that 143.35, and this time I'm multiplying by the molar mass. So 143.35 grams on top, 1 mole of silver nitrate on the bottom, or not silver nitrate, sorry, silver chloride. So multiply all the way across, 92 times 2 times 143.35, and divide it by everything on the bottom. 92 times 2 times 143.35. Divide that by 169.9 times 2. I get 77, how many sig figs are we looking at? 3? 77.6. So this would be my theoretical yield. If I used all 92 grams of that silver 1 nitrate, I would produce 77.6 grams of silver 1 chloride. All right, so the exam is due Wednesday by midnight. It's on the entire chapter 4. There's 28 questions. There is a practice exam, a paper one with answer key. There is a 5-question practice quiz that's on Blackboard. It's a Blackboard quiz, so you can see the format of some of the questions on the exam. There is a 2-hour time limit. No 2 exams are exactly the same. Numbers are constantly changing on those. So that's all due Wednesday by midnight. And then next class period, we're going to start chapter 5, which will be Wednesday. So there'll be 1 to 2 videos on chapter 5. There's already one posted now, actually, and then you'll have chapter 5 questions. So for chapter 5 questions, it's a Blackboard, it looks like a Blackboard quiz like I've made in the past, but you do get 3 attempts just like your other homework. It's not through the McGraw-Hill, so it's one that I made myself. So a little bit different formatting. Give me some feedback. Let me know if you prefer that over the McGraw-Hill ones, or if more people prefer the McGraw-Hill, the Connect ones, we'll switch back and do those instead. So that's all I have for you today.